So this was a pop quiz which was related to experimental techniques. The first question, results of some tests on the colorless liquid is there, X, and the boiling point is 102. So what is X? How we identify it? Look, as we know, when a substance is impure, the boiling point will increase. So if it was pure water, then what should be the boiling point of pure water? The boiling point of pure water is 100. But its boiling point is 102. So what does it mean? It means there is water, but it's not pure. So which one shows that it's an impure water? That is option D, like a salt dissolved in water or impure water, so that its boiling point is 102. If it was ethanol, the boiling point of ethanol is 78, so it should be a bit more than 78, like 80, 82, 84, but it cannot be 102. In question 2, a blue solid X is soluble in water. Which method is used to obtain pure solid X from the aqueous solution? Like there is a dissolve, we have a container and that container is having a solution of substance X. So salt X is dissolved here. We want to find the X from it, like we want to remove the substance X. So what we should do, if we carry out a crystallization and evaporation, because both crystallization and evaporation are used to separate the soluble substances. So chromatography is used to separate the dyes or the colors. Crystallization is used to separate the soluble substances. Filtration is used to separate the insoluble substance. And neutralization is actually when acid is reacting with the base. The reaction of acid and alkali is called a neutralization. So B is the right answer. A mixture is separated by using an apparatus shown. What is the mixture? So here because we are using a filtration, like filter funnel is there. So when we are using a filtration, it means the substance should be insoluble. Should not dissolve so that we can separate. Like one should be a liquid, another one is a solute, and that solute should be insoluble so that it does not mix and we can carry out by filtration to carry. So aqueous copper chloride and copper. So aqueous copper chloride and copper. Aqueous copper chloride, what does it mean? Like you have a copper chloride solution is there. So we have a copper chloride solution and it contains a copper metal as well. So if we carry out a filtration, when we carry out a filtration, so on the filter paper, what will happen? The copper will left on the filter paper and what passes through? The copper chloride will pass. Because one is a solution, aqueous means like solution dissolve, another one is a metal. Metals are insoluble in water. So when we carry out a filtration, we can separate them. Here, aqueous sodium chloride and copper chloride, it cannot be because both are aqueous, like both are soluble, dissolve. Methane and ethane, these are the gases. For gases, we use fractional distillation, and ethanol and water also miscible liquids. So for miscible liquid, we also use fractional distillation. That's why option A is the right answer. So we can separate a copper and a solution of a copper salt by filtration. Next is ethanol is made by fermentation. How is ethanol obtained from a miscible liquid? Like when we have a miscible liquids, two liquids which are mixed with each other. So which technique we use? We use a fractional distillation. So fractional distillation is a technique which we use to separate two or more miscible substances from each other. Like when two substances are mixed, we use fractional distillation. Alcohol and water are completely miscible. This means they form one layer. Which method? So again, a miscible, whenever you see a miscible liquid are there, so which method you use? You will use a fractional distillation. So if it was a soluble substance, soluble solute from the solution, we use crystallization. If it was insoluble solute from the mixture, we use filtration. And the precipitation is actually a type of reaction. It's not a technique. It's a type of reaction in which two solutions are mixed together to form a solid. In question 6, which two methods can be used to separate a salt from its solution in water? So salt is dissolved in water. So we can use crystallization. Decanting we cannot use because decanting is used for insoluble substances. Distillation or simple distillation can also be used. How simple distillation will work here? How simple distillation will work? Like example, we have a container which is filled with a solution. So there's a salt solution. When we supply heat energy, distillation or simple distillation is the same thing. When we supply heat energy, first what will happen? The water will, because the salt will left behind and the water will turn into vapor. And then it is connected to a condenser, the other side. So there is a condenser connected other side and then will remove the energy from this water vapor and the water is separated as a distillate on the other side. So water will be here and once all of the water evaporated, so we are left with a salt on this. So distillation can also be used to separate the soluble substances from the mixture or from the solution. Distillation or simple distillation. But filtration cannot be because filtration is used to separate the insoluble substance. So it is crystallization and distillation. So 1 and 3 are used to separate the salt from the mixture. A solid mixture contains ionic salt. The term ionic salt here, what does it refers to? It refers to that it is water soluble. When a substance is ionic, means it will be a water soluble. And a covalent organic compound, why? When covalent compounds are in water insoluble, does not dissolve in water. Not all of them, but most of them are insoluble. Like organic solvents are usually soluble in alcohol. You can simply remember if it's an ionic salts are water soluble, like they will dissolve in water. And if we have a covalent organic compound, then it will dissolve in alcohol, any kind of alcohol. So first, method 1, we shake with water. So when we shake with water, what will happen? X will dissolve, like the mixture of X and Y. We shake with water. So what will happen? X will dissolve and Y will not dissolve. So the solution, this will be X. And what is left on the filter paper, that is Y. Because Y is a organic compound. It does not dissolve in water. It dissolves in ethanol or alcohol. If we shake with ethanol, so what will happen now? This time, because it's alcohol, so Y will dissolve and X does not dissolve. So as the Y will dissolve, so this will be Y will dissolve and X does not dissolve. So we can use any of the solvent. We can use water here as a solvent. When we use water, the X will dissolve, Y does not dissolve. When we use alcohol, the Y will dissolve, X does not dissolve. So means both techniques will work. Both methods will work to separate X from Y. So that's why A should be the right answer. The diagram shows a method of separating a substance that contain X and Y. Which two substances can be separated? So what is this technique? These are all techniques to separate the mixtures from each other. This is like the main chapter is like separating mixture, two substances which does not have a chemical combination. Only physically they combine, so we call them as a mixture. So we use to separate the mixtures from each other. Because there is no chemical reaction, it's a physical change. In question 9, methanol and ethanol are miscible liquid. So if we have a miscible liquid, which technique we use? We use a fractional distillation. So which one is representing a fractional distillation? So this one is representing a fractional distillation. This is A is filtration, C is evaporation, and D is not a separation technique. It is just a chemical process which is called cracking. A mixture of a sulfur and iron filling need to be separated. The solubility of a sulfur and iron filling in water and carbon disulfide is shown. Means in water, the sulfur is insoluble, does not dissolve. Iron filling also does not dissolve. In solubility in carbon disulfide, the sulfur will dissolve and iron filling does not dissolve. What are the possible methods of separating a sulfur from an iron filling? Using a magnet. If you use a magnet, it will work. Why it will work? Because iron is a magnetic material. Like say you have a sulfur is there. You have sulfur and you have iron fillings. So if you bring a magnet, you bring a magnet north and south. So what will happen? These iron fillings will be attracted. So iron filling will be separated from the sulfur. So using a magnet, it will work. If you use water, like you have, say, sulfur is there, the yellow spots are representing sulfur and the black spots are representing iron fillings. So if we use water or if we add water, what will happen? Both are insoluble. So inside the water, if both are insoluble, even if you carry out a filtration, it won't work because both will remain on the filter paper. So it won't be useful using a water. And using carbon disulfide, when we use a carbon disulfide instead of water, if a carbon disulfide is used as a solvent, so carbon disulfide will dissolve sulfur. So sulfur will dissolve. So sulfur will be soluble and the iron fillings will be insoluble. So what will happen when we carry out a filtration? Iron fillings will be left on the filter paper and the carbon disulfide will, the sulfur which is dissolved in carbon disulfide will pass through the filter paper. So using a water, it won't work because both are insoluble, but using carbon disulfide, it will work. So that's why B is the right answer. Is it clear, this one?
Yes, sir.
Yes, sir. Clear.
Okay. So this was experimental technique pop quiz.